The ultimate origin story. We have all seen the documentaries, the computer-generated graphics. It always starts the same way. A black screen, absolute nothingness, and then a blinding flash of unimaginable light. A chaotic, infinitely hot soup of particles violently expanding outward, forging the foundation of reality in a fraction of a second. It is loud, it is aggressive, and it is what we call the Big Bang. We accept it as the absolute, unquestionable truth of how everything began. But what if that entire picture is completely backward? What if the universe didn't begin with a fiery explosion, but with absolute silence, profound stillness, and a cold so deep it defies human comprehension?
That is exactly the kind of paradigm-shifting question that keeps cosmologists and theoretical physicists awake at night. We have this deeply ingrained cultural and scientific assumption that the universe was born in a chaotic inferno. But there is a radically different, almost haunting alternative that is quietly gaining traction. Imagine the exact opposite of that violent explosion. Imagine a state of cold so profound that the concept of temperature itself ceases to exist. A frozen, silent nothing that suddenly began to melt. We are talking about the Big Defreeze hypothesis.
The Big Defreeze. Just hearing the phrase sends a bit of a shiver down the spine. It implies that the explosive moment we call the Big Bang wasn't actually the first chapter of the story, but merely a transition, a cosmic melting point. It completely flips the script on how we view existence. If we started in the deep freeze, how in the world did we get to this warm, bustling, expanding universe we live in today?
To figure out how the story truly begins, we actually have to fast forward to the very end of the book. Astronomers and physicists have spent decades debating how our universe will eventually die, and they generally fall into three main camps. The first is the Big Crunch. This is the scenario where the gravitational pull of all the matter in the universe eventually overpowers the force of cosmic expansion. Everything slows down, stops, and then gets pulled back together into a single, infinitely dense point. It is essentially a reverse Big Bang.
Right, the cosmic yo-yo effect. The universe breathes out, and then it breathes back in. But as our measurements of the cosmos have gotten better, that theory has lost some ground, hasn't it? There are much more violent endings on the table now.
Exactly. The discovery of dark energy changed everything. That leads us to the second scenario, the Big Rip. In this model, the dark energy driving the expansion of the universe doesn't just push galaxies apart. It accelerates so aggressively that it eventually overpowers all other fundamental forces. It literally tears everything apart. Galaxies are shredded, then stars, then planets, and in the final moments, the very atoms that make up our bodies are ripped into subatomic nothingness. It is a sudden, violent tearing of the fabric of reality.
Both of those sound incredibly dramatic, almost cinematic. But the third option, the one that the majority of the scientific community seems to be leaning toward these days, is much quieter, and honestly, much bleaker. The Big Freeze.
The Big Freeze, also known as heat death. In this scenario, the universe just keeps expanding. Forever. As it expands, the finite amount of energy within it gets spread thinner and thinner across an increasingly massive volume of space. Stars burn through their nuclear fuel and go dark. Galaxies drift so far apart that their light can no longer reach each other. Eventually, even the last supermassive black holes evaporate into faint radiation. The universe becomes a vast, dark, unimaginably cold void. It reaches a state of maximum entropy where no more thermodynamic work can be done. Everything just stops.
So, if the most mathematically likely destiny of our universe is to end as a dark, frozen wasteland, why is it so hard to imagine that it might have started exactly the same way? Nature loves symmetry. If we are inevitably heading toward a big freeze, maybe we emerged from one.
That is the exact leap of logic that birthed the Big Defreeze hypothesis. It looks at the end to understand the beginning. But to truly grasp what a frozen beginning looks like, we have to abandon our everyday understanding of physics and dive headfirst into the incredibly weird, counterintuitive world of quantum mechanics. Specifically, we need to look at what happens to matter when you cool it down to absolute zero.
Absolute zero, negative 273.1 degrees Celsius. The theoretical baseline of temperature where all atomic movement, all kinetic energy, completely stops. It is not just cold, it is the physical absence of heat altogether.
Precisely. And when scientists isolate atoms in a lab and cool them down to just a tiny fraction of a degree above absolute zero, those atoms stop behaving like individual particles. Normally, atoms in a gas are like a chaotic swarm of bees. They are buzzing around, bumping into each other, bouncing off walls, each with its own distinct trajectory and energy level. But at that extreme, punishing cold, they undergo a bizarre phase transition and form a new state of matter called a Bose-Einstein condensate.
I love the analogy that is often used to visualize this. Think of a massive sports stadium filled with tens of thousands of fans. Before the game starts, it is pure chaos. People are buying food, talking to their friends, walking up and down the aisles. Everyone is an individual acting independently, doing their own thing. That is normal matter. But then, the crowd starts doing the wave. Suddenly, all those distinct individuals are moving in perfect synchronized unison. They lose their individual behaviors and become part of a single, massive, flowing entity.
That is a brilliant way to picture it. In a Bose-Einstein condensate, the atoms literally lose their individual quantum identities. Their wave functions overlap and merge. You can no longer tell one atom from another. It becomes physically impossible. They share the exact same quantum state, acting as one giant, unified superatom. Now, take that concept, which we have proven in laboratories, and scale it up to the size of the entire cosmos at the moment of inception.
So the Big Defreeze hypothesis suggests that before the Big Bang, the universe was in a hot, dense, infinitely small point of chaotic energy. It was a single, perfect, frozen quantum wave. A cosmic Bose-Einstein condensate, the ultimate state of stillness.
Yes. In theoretical physics, this proposed state is sometimes referred to as the identity stem wave. It is a state of absolute, unbreakable symmetry. There were no distinct particles. There was no light, no heat, no gravity as we currently understand it. Just a silent, unified, frozen potential stretching across whatever space existed. And here is where it gets deeply philosophical. If there is no movement, no vibration, no change, and no entropy, does time even exist in that state?
That is a staggering thought. If time is just the measurement of change, the progression of events from one state to another, then a perfectly frozen universe is entirely timeless. It is an eternal present. There is no past or future, just a static now. So the real question, the million-dollar mystery, is how do you break eternity? How do you get from a timeless, frozen block of nothingness to the explosive, chaotic birth of everything we see today?
You introduce a tiny flaw. You introduce energy. Think of a perfectly smooth, solid ice cube sitting on a table. It is highly structured, rigid, and perfectly still. But the moment you start adding energy, heat, that rigid structure is compromised. The water molecules begin to vibrate against their bonds. The ice cracks, it melts into a puddle of liquid water, and if you add enough heat quickly enough, it violently boils into steam, expanding rapidly in all directions.
So the Big Bang was just the ice cracking. It wasn't the magical creation of the universe out of nothing. It was a phase transition of a pre-existing universe. The moment the frozen symmetry shattered.
Exactly. The Big Bang was the thaw. Something, perhaps a random quantum fluctuation, a microscopic ripple in that perfect stadium wave, introduced a spark of energy into the system. That tiny injection of energy caused the perfect symmetry of the identity stem wave to break. In quantum field theory, this is known as symmetry breaking, and it is the mechanism that gives particles their mass and creates the fundamental forces. When that cosmic symmetry shattered, it released a staggering amount of latent energy, causing the universe to rapidly expand outward.
It fundamentally changes our relationship with the cosmos. It means the fiery explosion wasn't a beginning, but a consequence. It was the universe losing its perfect, pristine order and falling into a state of chaos, which actually aligns perfectly with the second law of thermodynamics, doesn't it? The unbreakable rule that the universe is always moving from order to disorder.
Spot on. Thermodynamics dictates that entropy, which is the measure of disorder in a system, always increases over time. A hot, chaotic Big Bang always felt a bit counterintuitive to some physicists because it suggests the universe started in a state of high energy and immense pressure, yet somehow had low entropy. But a frozen, perfectly symmetrical Bose-Einstein condensate? That is a state of incredibly low entropy. It is the ultimate blank slate of order. It makes perfect physical and logical sense that the universe would start in a highly ordered frozen state, shatter into the chaos of the Big Bang, and then slowly cool down as that chaos spreads out.
But here is the skeptical angle, because we have to play devil's advocate. This is a beautiful narrative. It is elegant, it is poetic, and it solves some profound philosophical headaches about the nature of time and beginnings. But science isn't poetry. It requires proof. How on earth do you test a hypothesis about a frozen universe that existed before the Big Bang? We can't exactly stick a thermometer into the pre-cosmic void.
You are absolutely right to demand evidence. Theoretical physics can easily drift into science fiction without empirical data. But we actually do have a way to look back at the echoes of that creation event. Scientists look at the cosmic microwave background radiation, the CMB. It is essentially the afterglow of the Big Bang itself, a map of the oldest light in the universe, imprinted on the sky. And to analyze the tiny temperature fluctuations in that map, they use a complex mathematical tool called a Fourier transformation.
A Fourier transformation. That sounds incredibly intimidating, but the underlying intuition is actually quite beautiful. If you hit a complex, dissonant chord on a piano, you hear one unified, dense sound. But that sound is made up of several different, individual notes played together. A Fourier transformation is basically a mathematical prism. It takes that complex, messy chord and separates it out into the individual, pure frequencies that created it.
That is exactly how it works. Cosmologists take the incredibly complex noise of the early universe's energy distribution, those tiny ripples in the cosmic microwave background, and run it through this mathematical prism. They are looking for specific spikes or frequencies in the data. If the universe started as a chaotic random explosion from a singularity, those frequencies should look a certain way. But if it started as a single unified quantum wave that suddenly defrosted and shattered,
then the mathematical echo of that shattering should match the frequencies of a defrosting quantum wave. We should literally be able to see the specific acoustic signature of the cosmic ice cracking.
precisely. And while the data is still being rigorously gathered, analyzed, and debated by the global scientific community, some of the patterns we see in the cosmic background radiation align remarkably well with the mathematics of a shattered Bose-Einstein condensate. The energy spikes match the predicted frequencies of a phase transition from a frozen state. It is a tantalizing hint, a whisper from the dawn of time, suggesting that our universe might just be a giant melted puddle of quantum ice.
It makes you look up at the night sky entirely differently. It strips away the violence of the Big Bang and replaces it with a strange sense of peace. We aren't the byproduct of a random, aggressive accident. We are part of a grand, sweeping thermal cycle, a cosmic season.
A cosmic season is the perfect way to phrase it. We started as a frozen seed, waiting in timeless silence. That seed cracked open, defrosting into the brilliant, hot, violent expansion that created the galaxies, the nebulas, the stars, the planets, and eventually, us. But the heat won't last forever. The expansion continues, the energy dissipates, the stars will eventually fade, and we are slowly, inevitably heading back toward the big freeze.
We are literally living in the warm summer between two eternal winters.
We are. And there is something incredibly humbling yet elevating about that realization. It puts our entire human existence into a breathtaking perspective. Every empire that has ever risen and fallen, every piece of art we have ever created, every scientific discovery, every moment of love, joy, or sorrow, it all happens in this brief, fleeting cosmic thaw. We are the children of the melted ice, thriving in a temporary pocket of warmth before the universe returns to its silent slumber.
It poses such a profound question about the nature of existence itself. If the universe cycles from frozen stillness to chaotic warmth and back to frozen stillness, does the cycle repeat? When the next eternal winter sets in and the universe reaches absolute zero once again, does it form a new identity stem wave? Does a new seed wait in the dark for another quantum ripple to spark a new thaw?
That is the ultimate mystery, the frontier of our understanding. Quantum field theory suggests that even in a complete vacuum, even at absolute zero, there are always tiny, inescapable quantum fluctuations. The potential for energy is never truly gone. It is just dormant. So it is entirely possible that heat death isn't a final grave. It might be a cocoon, a resetting of the cosmic clock, preparing the stage for the next universe to bloom.
A resetting of the clock. It makes you realize how precious this warmth is. We spend so much of our lives worrying about the daily grind, the immediate future, our localized anxieties. But zooming out to this scale, it is strangely liberating. We are awake during the universe's brief summer. The ice has melted just enough to allow complex chemistry to form, to allow biology to evolve, to allow us to exist, to think, to look back at the cosmos, and try to understand the very mechanics of our own creation.
And perhaps that is the true hidden purpose of the thaw. A frozen universe is mathematically perfect, but it is blind. It has no observers. It takes the messy, chaotic warmth of the defreeze to create complex structures like the human brain. We are the universe experiencing its own summer. We are the mechanism by which the cosmos understands its own beauty and its own fleeting nature.
That is a staggering thought to leave off on. We are the universe experiencing its own summer. The next time you hold a glass of ice water and watch the cubes slowly melt, or step out into the freezing winter air and feel the heat escaping your breath, take a moment to think about the sheer scale of what that represents. The transition from cold to warm, from stillness to motion, is the very reason we are here to witness it at all. It is not just a physical process. It is the heartbeat of reality itself.
A heartbeat that spans tens of billions of years. It is a beautiful reminder to appreciate the warmth while we have it, to seek out knowledge while the light still shines, and to marvel at the profound, silent mystery of the cold that bookends our entire existence.
Beautifully said. We are suspended between the frost of the past and the chill of the future, basking in the light of today. Thank you all for joining us on this deep dive into the cosmic thaw. Keep looking up, keep asking those massive questions, and never stop wondering about the silence before the bang.